Hi, and welcome back to our ninth session about the GitLab DevSecOps pipeline which we are building. In this session, we will look at the capabilities and the limitations of the vulnerability management of GitLab. In our previous session, we have introduced this DevSecOps pipeline, which you can see up here. Our DevSecOps pipeline, which we are building with GitLab, consists of continuous integration and continuous delivery. In our previous sessions, we have introduced several tools to our DevSecOps pipeline. You can see up there and also in the video description all the links to all the tools where we have created a separate video for you.
And these tools include software composition analysis, where we analyzed dependencies of your own code, license compliance, where we looked at what open source and commercial licenses your code depends on, static application security testing, where we inspected your own code and were looking for vulnerabilities in there directly, container scanning, that was looking at the container image and vulnerabilities from within there, and secret detection, where we were looking whether you have secrets like keys or passwords built into your source code or your configuration files. All these were part of the continuous integration step. This is also known as the build stage within GitLab. In addition, we had the dynamic application security testing, something like a penetration test, and this one we executed within its own stage, the test stage.
As you can see, we have now introduced into our DevSecOps pipeline quite a lot of tools. And all of these tools, they are generating quite a lot of vulnerability findings. And now the question is how to manage all of these vulnerability findings. Hey, Paddy, now we have all of these vulnerability findings and we need to manage them. What has GitLab to offer?
GitLab in the Ultimate Edition offers us a vulnerability management tool that's included and integrated within their platform. This tool is all about managing and tracking vulnerabilities found by all the other security tools and scanners. It includes a security dashboard that provides you with an overview of the number of vulnerabilities that are there and how they developed over time. In addition, we have a vulnerability report view, which allows us to view and track individual vulnerabilities from all the tools. Be aware that the data presented in the security dashboard and the vulnerability report always boil down to your default branch within GitLab. The default branch is something you can configure within GitLab for your project. If you didn't change that setting, it's set to be the master branch, which it is in our case too in this pipeline we built together. So this means in our case, all the vulnerabilities reported are just for the main or master branch in our project. What capabilities now offers this tool?
One of the core capabilities which we have, of course, in the vulnerability management is that we can sort and filter by tool and also by criticality. And when we have such a finding, we of course want to create an issue so that the finding gets resolved. And this is also something we can do directly in GitLab. We can create an issue in the own issue tracking system of GitLab. And of course, you need to be able to mark findings as fixed or as dismissed. This can be the case, of course, when it is a false positive or if it is an accepted risk. And one of the very cool features of GitLab is that when we run again our pipeline with some changed code, it also detects if a vulnerability has already been fixed. This vulnerability is then marked as potentially fixed, and we are able to mark it as fixed. You can also integrate other tools which scan for vulnerabilities, but the report that they generate needs to be exactly in the GitLab expected format. And of course, you can add your own vulnerabilities that you are finding and then track these in the vulnerability management. So, Padi, you are the expert when it comes to security. What are the limitations of this vulnerability management?
While the GitLab Vulnerability Management tool is a good starting point for many of us, it also has its limitations, as Romano questioned for. First of all, you cannot comment on the reason why something was actually dismissed. So if you dismiss an item, you will never have an idea why you dismissed it. Besides that, you also cannot dismiss for just a limited time. So it's not possible to say, okay, I'll accept this risk and dismiss for, say, 6 months, and then I want to review that risk. Also, dismissing means either risk is accepted or it means, well, that was a false positive. It's basically not what we want. We want to distinguish these two. Obviously, we also will have many false positives. This is nothing GitLab Vulnerability Management can change because it's inherent within the security tools we integrate. And it usually applies for all the security tools we have. Then, as Romano pointed out, when you integrate your own security tools, they need to be able to deliver their result in a format that's specified by GitLab. What we instead would expect from a vulnerability management tool is that it's flexible and can adapt to many different formats of reports, because it is the actual integration hub and it should be flexible. Not all the tools around should be focused on this vulnerability management tool of GitLab. Then, when it comes to adding your own vulnerabilities you found, say for example, you have done a manual penetration test and want to add a finding. In that case, GitLab will require you to add unreasonable fields, like for example the CVE ID. But you don't have such an ID in your case, so why should you be required to add it? On the other side, the data you can actually add is very limited. So that's not much of commands or additional information you can add to such a manual made finding and manually added finding. Another thing that I witnessed was when I changed source code, the finding that already existed wasn't pointing to the right position in the code anymore.
So enough from the theory part. Let's have a concrete look at how this looks like in GitLab.
Cool, let's do that.
So we are back in the source code. We see here our repository, and what we are going to do is we go under security and compliance to vulnerability report. As we can see, the vulnerability report has been generated on the default branch. GitLab also points that out for us. GitLab also tells us in the vulnerability report that we have at the moment 165 vulnerabilities in this simple Java project. We have 35 critical, 70 high, 48 medium, 11 low, 0 info, and 1 unknown. As previously said, we can filter these vulnerability by tools. You can see here the tools that we have in place, like SAST, dependency scanning, or also DUST. When we click on SAST, then the vulnerability report will be filtered according to this tool. When we go back to all tools, then we can again see all of the vulnerability results, and then we can also say we would like to see all of the high vulnerability, which then our vulnerability report will be filtered on. Now we can also open such a finding. I open that in a new tab, and here we can see an extended description on that finding. Here we have a container scanning finding where we have a problem with a SSL library in this image. Let's head back to our vulnerability report and change the severity to all severities. Here we can now see a critical severity where we have this AWS access token detected by the secret detection. And here we can even see where exactly this has been found. You can see here our private final string, the ID for the cloud, where we have the secret. We are heading back to the vulnerability report, and what we also want to show you is the security dashboard. In the security dashboard, we can see the development of the security vulnerabilities over the amount of time. We can even change here this report so that we can display the whole report over a time, and we can see here, for example, how our high and critical vulnerabilities have developed over time. Hey Paddy, can you show me how to manually add a finding in GitLab?
Sure. For this, we go back to vulnerability report in the security and compliance port. Next, we select submit vulnerability. We have to add a name of our finding. Say we had made a penetration test and find a cross-site scripting exploit. We can add a description as we want. We then can select the severity of the finding, say it was a high, and also the status. And because we already found that one and confirmed that one, I even set it from the beginning to confirmed. Then we add the proposed solution. And I can submit it. Now it didn't accept it. So why? The reason is, and that's another shortcoming, it requires us to enter an identifier code and a URL. But I don't have such a thing when I did a penetration test. So the workaround is just add anything. And submit again. Now we have our vulnerability added. Let's search for it in the vulnerability report. I select for that manually added as the tool. And we have here our vulnerability. Next, let's see how we can actually assign a finding to a developer, or so to say, create an issue or a task for a developer. Head back to the vulnerability report, then open the finding we want to assign or create an issue for, and just select Create Issue. And here you just add your typical issue description part, like title and so on. If you're done, just select Create Issue. Now we see that we can also navigate back to the vulnerability that actually was used to create this issue. So this is kind of two-way, and it's two-way because we see the linked items here. That's the issue we created. Creating an issue might also be your workaround for the limited capabilities when it comes to kind of adding additional information why you dismissed an item, for example, or to kind of have a track record of what activity were done to kind of fix a vulnerability. Also on the vulnerability report, we see where we have assigned issues. For that, we can filter by with issues. And sure enough, we see that we here have an added issue. I clear the filter again. And let's take a look at the status part. As of now, we have mostly needs triage as the status set. Needs triage means this issue was detected and it's a potential finding that should be fixed. Our job is now to investigate and analyze whether this is a confirmed issue or whether it is a false positive. Let's say we've investigated this finding and issue here, and we found that yes, this is an actual problem. So we set it to confirmed. I mark it, select confirm, true positive, that should be fixed, and change its status. Next, let's say we found that this other finding here, well, that was a false positive. So I can select it too, select dismiss, and change the status. Please note that I hadn't the opportunity to say why I actually dismissed this finding. So I couldn't select whether it was a risk acceptance. So I said, okay, I accept this risk and just go on with it. Or whether it was a true false positive, so something the tool was not right about. So now let's fix some issues and take a look how this changes the view of this vulnerability report. So let's fix some issues. For this, I'll go back to the repository. And as I want to fix some dependencies, I'll open the POM and open it in the web ident editor. So I changed the version from 2, which has a lot of vulnerabilities, to the current one that's about 2.7.2 at the point of recording. And because I update my Spring Boot now, I also need to update the testing because Spring Boot actually changed the testing framework in that time. For this, I head to the sources, in my test, obviously. So I fix this stuff here by adding the new dependencies, and then I can commit. Let's see what the pipeline did in the meantime. So looks like our pipeline actually did run. We still have some vulnerabilities that were found during that pipeline run. It's significantly less than before, but let's see what the report tells us. For this, I head back to Security and Compliance and Vulnerability Report. Now on first sight, it looks like we still have the same number of findings as before. But let's see what happens when we filter by activity with no longer detected. So what we see here is that we actually have a number of findings that now are no longer found by the security tools. It's quite a few actually. So just updating our Spring Boot led to the situation where we have fixed lots of findings. Now, because the tools are not always sure whether they detected something right, they just mark a finding as, well, it's no longer there. Tell me what this means. And in our case, we can say, well, all these that regardless of the status, but if they are no longer detected, then we say for the purpose of this exercise, we say, well, all these are really fixed. So we set the status to resolved. And as before, resolved means, well, the issue is no longer there, but I don't have a chance to add information at this point in time. So this information is kind of lost. Now let's see how many findings are still there that are not resolved. So they need triage, they are confirmed in any of these states. And we still have some that are no longer detected filter in there. So we can also mark these as fixed. I filter now by just things that are still open. So needs triage, confirmed, and all activities. And we still see that we have a number of findings, but they are clearly fewer. You may have noted that the vulnerability report didn't update these numbers, so I hit refresh in the browser and it should present me with the new cross totals.
And this concludes our session about the GitLab Vulnerability Management. We have seen that with GitLab we can manage all of the vulnerability, that we can sort and filter all of these vulnerabilities, and that we even can create issues for our development team so that these vulnerabilities can be fixed. And with that, we are at the end of this video. In our next video, we will have a look at how we are going to deal with merge requests.